Here is my video about oxidizing alcohols, which I can't believe I have not made yet. Before you figure out what the products of oxidizing alcohols are, you need to figure out if the alcohol is primary, secondary, or tertiary. The way that we do that is to take a look at the carbon that has the OH on it. That's this carbon in this case. And how many carbons is it connected to? In this case, that carbon that has the OH is only connected to one other carbon. That makes it primary. This OH is connected to a carbon that is connected to two other carbons. That makes it secondary. And here the OH is on a carbon connected to three others. It is tertiary. There's no such thing as a quaternary alcohol because carbon can't have 5 bonds. Okay, now this O in square brackets usually represents some kind of oxidizing agent. Very often it's dichromate, that's Cr2O7 2-, present as potassium dichromate, and usually you'll want some heat as well. It's called reflux conditions. The first oxidation that happens to primary alcohols converts it to an aldehyde. Now this is a 3-carbon chain with an OH at the end. So I want a 3-carbon chain as the product, and I convert it to an aldehyde by making it a double bonded O instead of a single bonded OH. Oxidation here is actually the removal of this H and the removal of an H off of this carbon to create this double bond. It is a long, complicated process. I'm not even sure that chemists know exactly how it works fully. I think it's 40 steps or something like that, but don't quote me on that. What matters here is that the product of oxidizing a primary alcohol is an aldehyde. Aldehyde. Now, aldehydes can be further oxidized by refluxed dichromate. They become carboxylic acids. So I'm going to redraw my aldehyde, but instead of having an H on this terminal carbon, I'm going to replace it with OH. Oxidation here means adding that oxygen in between the carbon and the hydrogen. Now, if you ever want to stop at the aldehyde, you need to do something called distillation, where the aldehyde is evaporated and then condensed separately, because if the aldehyde stays in this solution, it's going to oxidize to the carboxylic acid. If you want the carboxylic acid, just let it go all day and do reflux dichromate and it's going to happen. But primary alcohol becomes aldehyde, becomes carboxylic acid, is something you will have to remember and be able to predict the structure for. A secondary alcohol undergoes a similar reaction to this, except a double bonded O in the middle of a chain is called a ketone. Redraw the carbon chain, but the single bonded O becomes a double bonded O. This is a ketone. It is almost the exact same method of predicting the structure as we did for primary alcohol to aldehyde, except it's called a ketone because the double bonded O is not at the end of the chain, it's in the middle. Cool? Cool. Now, tertiary alcohols, in order to make this O double bonded, you would have to break a carbon-carbon bond. These conditions are not strong enough to do that, and so tertiary alcohols do not react under these conditions. If you ever needed to tell the difference between a primary or secondary or tertiary alcohol, you could put it in dichromate, and if there's no reaction, you know it's tertiary. If there is a reaction, you know it's one of these two. The last thing I want to point out is that this dichromate solution originally starts as orange. And as the reaction progresses, the Cr2O7 2- ions become Cr3+ ions, which are green. So you can physically watch the reaction change color from orange to green if primary or secondary alcohols are being oxidized. It's pretty straightforward, but that's everything you'll need to know as a high school student. Maybe even first year university. I don't know. I don't go to school where you do. Best of luck.